Good evening, everyone. Am I audible? Hello. Am I audible to you?
Yes, yes, it's audible.
Okay. Thank you. Okay. So we'll start now. Um, my name is Ranjan Bora, and I am a PhD research scholar at IIT Delhi. I am one of the TA in this course, Biomechanics of Joints and Orthopaedic Implants. This course is instructed by Professor Sanjay Gupta from IIT Kharagpur. Today is the week 3 of tutorials, and previously I have taken two lectures, two tutorials, week 1 and week 2. I hope all of you have gone through those videos. In those videos I have discussed some basic mechanics problems and solved the assignment questions from previous weeks. In today's tutorial, first I will solve the assignment of week 2, and after that I will discuss some concepts from week 3, and after that, I will solve some numerical problems related to biomechanics. So first I will solve the week 2 assignments. I hope all of you have submitted the assignment. So this was the first question. Which of the following movement is associated with elbow joint? Very easy question. What is the answer?
Pronation.
Yes, pronation. We have discussed in the last class. Like pronation is the movement of our forearm. When the forearm movement is like our palm is facing anteriorly, then it is supination, and when the palm is facing posteriorly, it is pronation. Next, which of the following bone is not associated with knee joint?
Tibia.
Yeah.
Tibia, right?
Sorry, fibula. Yes.
Fibula.
Yes. As you can see from this figure, this is the tibia bone, and this bone is directly linked with the knee joint. Here is the knee joint, and fibula bone is slightly below these joints. So B is the correct answer. What is the angle between the long axis of the extended forearm and the long axis of the upper arm?
Carrying angle.
Yes. You can see from this figure, the long axis of the extended forearm means this axis, and long axis of the upper arm means this axis. So this is the angle, and this is known as carrying angle. From where this name came from, the carrying angle? This name came from while carrying some objects, and carrying the objects then moving, like taking it from one place to another, this angle becomes useful. And with this angle, while walking, we clear our hip. Like while walking, our forearm moves in a sync movement with our legs. So because of this angle, we can walk. What is the degree of freedom corresponding to glenohumeral joint? Yeah. This is the glenohumeral joint, and what kind of joint is it? Is glenohumeral joint? Like if we want to model it as a mechanical joint, how do we model a glenohumeral? Yes. So in a spherical joint, considering this as a sphere, and this is the cup where the sphere is fitted.
Ball and socket. Ball.
It is not a ball and socket. It is called a spherical joint. Ball and socket is also, yeah, ball and socket is also same, but that means thus it is slightly different. Means the degrees of freedom is same. In case of ball and socket joint, it is also 3, and in case of this spherical joint, it is also 3. We can only have these movements. And one movement will be, I think this way. So we can have 3 rotation movements. That's why this has 3 degrees of freedom. Degree of freedom of knee joint, like in our, yes, in our last class we have discussed this. It can have, the knee joint can have the translation movement, and along this axis it can also have the rotation movement. Similarly, it has 3 axes. That's why it has 6 degrees of freedom. What is the angle of inclination of the femoral neck to the shaft in the coronal plane? What is this angle known as?
CCD.
Yeah, NCCD stands for this Kappa column diaphyseal CCD. The articulation formed by the clavicle and the scapula is often referred to as which articulation it is talking about? It is talking about this articulation at this point. So at this point, what is this joint known as? Yes, yes. This is the joint, acromioclavicular joint. Which of the following muscles does not have a role in the rotator cuff, which provides both motion and stability at the glenohumeral joint? These are the rotator cuff muscles as shown in this figure. So you can see these muscles have the teres minor, then infraspinatus, supraspinatus, and subscapularis. So we don't have teres major. So A is the right answer. The connection is a closed chain mechanism. What is the answer?
Thorax, clavicle, scapula. Is that right?
Yes. You can see this clavicle, then this is the thorax, and this is the scapula. Means in this case, all these links are connected to two adjacent links, and that is the definition for closed chain mechanism. And this is the definition: kinematic chain with every link connected through joints to two adjacent links. That's why C is the right answer: clavicle, scapula, and thorax.
Sir, option D is also thorax, clavicle, scapula. And also
Okay,
C.
okay, yes. Hmm.
What is the difference?
I think same or
Can you define once again this question?
yeah. C means this is the clavicle. I am drawing here. This is the clavicle, and connected to the clavicle there is scapula, and we don't see the connections here. We can see there is a connection to the thorax here with the clavicle. So you can see this clavicle is connected to both scapula and thorax. This is thorax, clavicle, scapula. So according to the definition of closed chain mechanism, when every link connected through joins to two adjacent links, that means if we consider this clavicle as a link, then this link is connected to two adjacent links. means we are considering every part as a link. Clavicle as a link, scapula as a link, and thorax as a link. So every link is connected to all the neighboring two links. You can see like scapula is connected to both clavicle and thorax, and similarly thorax is connected to both clavicle and scapula. That's why it is a closed chain mechanism.
Sir, why not this option D, sir?
Which option?
Why not the option D is right?
Yeah, I will clarify this. Means I think both are same. I think there might be some mistake. I will clarify in the next class. Is it okay?
Yes.
Okay. Next,
Yes, yes.
sorry. Squatting is an example of
Open chain.
yeah, Rindam. I will discuss about this in next class. Yeah, what is the answer? Squatting is an example of.
C, open chain.
No, it is not an open chain.
Closed chain, right?
Yes, yes. Like if you have seen my previous week video, in this video we have discussed in brief what is a open chain and closed chain, and we have discussed some examples of performing exercises, like which exercise is open chain and which exercise is closed chain. Again, this definition is there in the slide. Terminal link meets enough resistance to restrain its free motion. If this condition is satisfied, then it is a closed chain mechanism. And here you can draw the links, like this is a link, then this link is connected with this part here, and we can draw the whole body as a link, one link. So you can see the terminal link means the link which is at the end. So these two links are terminal links.
Sorry, your video is not visible.
Is it not visible?
No.
Okay. Is it
Yes.
visible for
Now it's
others?
visible. Yes, yes, yes.
Okay, there might be some internet issues in your case. Please check that.
Maybe.
Yeah. So these two links are the terminal links, and here the terminal link, like you can see, below this point, the terminal link cannot move. These are the ending point for these terminal links. So these links act as these links are fixed to these points. That's why it is a closed chain mechanism.
So, please tell me any one exercise which is open chain because I was not present in previous lecture on this.
Okay, like when you are doing, wait, I will see if my previous videos are there. See, can you see here?
Yes.
So this exercise, the first one, this one. So in this exercise, what he can do, the terminal links are not fixed, right? These are the terminal links, this hand. So he can freely move his hand. The hand which is holding the dumbbell, it can freely move, right? Yeah, so this is an example of open chain. This is, and we have discussed this is a closed chain because here the terminal links are fixed here. Okay. This question, which of the following factors influence the joint degree of freedom? Yeah, it is D. For the shape of the articular surface and the number of ligaments.
So can you explain this question by an example?
Yeah, like what is degree of freedom? What do you understand by degree of freedom?
So the degree of freedom is that it shows the
The
direction in which it
Yeah,
is going.
the independent number of movement a joint can have. So like previously we have seen in case of knee joint we have 6 degrees of freedom, and in case of glenohumeral joint we have the 3 degrees of freedom. Those are the independent number of movements which the joint can have. Means those movement does not depend on the other movements, other constraints. So, and in case of degree of freedom, here it is not talking about those factors. Here it is talking about the how the joint is formed. Like uh, in case of hip joint, we have this femur, and then we have this acetabulum cup. The femur is inside this acetabulum cup. So it acts as a ball and socket joint. Like it depends on shape of the articular surface, right? First option. If it is not this shape, if it is like some kind of, imagine some kind of shape like this, then it would have different number of different degree of freedom, right? So
Just like knee joint,
yes,
we have a meniscule which they femur.
yes means the it depends on the shape of the articular surface. What is the shape of this surface? And then the number of ligaments, because ligaments also influence its movement. Like in this case we cannot explain that, but in case of other joint, like we have one joint here in our hand, we have humerus, then we have radius and ulna. So between radius and ulna there are some ligaments which hold radius bone to the ulna bone. This is humerus, this is ulna, and this is radius. I am giving just an example. So between this radius and ulna bone there are some ligaments which means which hold the other bone which is ulna. So because of that these two are in a fixed position, means it can't go, the ulna bone get uh, can't get away from the radius bone. It is always in contact with this radius bone because of this ligament. So ligaments also influence how a joint behave, how the how there is a movement in the joints. So is it clear?
Yes, sir.
Okay. Okay. The acromion, medial border, lateral border, and the spine are all bony landmarks associated with which of the following bones? Yeah, yeah, it is scapula. Like if you see a figure figure of scapula, you can see here. It is talking about the acromion. Acromion is here. Then the medial border. This is the medial border and lateral border. Spine is not shown here. Spine is somewhere here. So all these bones are connected with scapula. Means all these landmarks. These are the landmarks, bony landmarks. Which is the major load-bearing joint at the shoulder? Yeah, glenohumeral. Yes. The dash provides mechanical advantage by increasing the lever arm of the quadriceps tendon. Which joint it is talking about? Yeah, knee joint. And, and in the knee joint, you can see this figure. See, if there is no patella, then these are the line of actions of the forces of the quadriceps muscles. And if there is patella, then patella, because of patella, the line of actions get shifts to right. From this point, it shifts rightward. That's why we get the mechanical advantage. Like we increase the momentum. If we increase the momentum, then these muscles need to produce less forces because moment is R cross F. If we increase R, then force is decreased. That's how we get the mechanical advantage. The patellofemoral joint is subjected to a dash, that is the resultant summative force of the vectors of the patellar tendon and the quadriceps tendon forces. What is the answer? Yeah. So you can see, yes, A is correct. These are the quadriceps force and this is the patellar tendon force. And the resultant of this force acts towards this direction, and this is a compressive force for patella. So A is the right answer. Okay, next question. A varus deformity is an excessive angulation of the distal segment of a bone or joint.
Outwards,
No, no.
inwards.
Yeah, it is talking about this hip joint. See, this is a varus deformation, right? The coxa vera. And this is normal. So, in case of normal, we have this orientation. And in case of coxa vera, we this this angulation is little bit inward. That's why A is the right answer. Which region of the spine carries the maximum load?
Lumbar.
Yeah, yeah. So spine has these four regions: cervical, thoracic, lumbar, and this pelvic sacrum. So this lumbar region carries the maximum load. Which of the following is a spine flexor muscle?
Erector spine.
No. See, in this figure, which are the spine muscles? We have two spine muscles. One is psoas major muscles, and one is this erector spinae muscles. This is like a cross section of an abdomen near to the thoracic spine. So you can say spine is connected to two muscles. One is this and one is this. And which one is the flexor muscle?
Psoas.
Yeah, psoas is the flexor muscle.
So the erector spine will be extension.
Yeah, extensor muscles it will be. Which of the factors affect the spinal load during lifting of an object from ground?
Posture.
Yeah, posture is one option.
All about it.
Yeah, like from this figure you can see the posture of this man, then size of the object, then the weight of the object. In the slides, this problem is solved. Like for these three conditions, what will be the moment which will act at this lumbar region of spine? So it depends on all of the above: posture, size of the object, weight of the object. This question: a man is carrying a 200 Newton object in standing position. Calculate the bending moment acting on the lumbar disc. What is the answer?
60.
Yeah, the lumbar disc is here. So from here, the distance is this much. This is r equal to 15 plus 15, because the weight of the object will act through the center of gravity of the object, which is at this the midpoint. So it will be 30. Then we have moment equal to r cross f. R is 30 cross 200 Newton. So it will be Newton centimeter. So if we convert to Newton meter, it will be 60 Newton meter. Now, in the week 3 videos, week 3 is mainly focused about the gait cycle and different gait phases, then measurement techniques of gait. So have you all have gone through the videos, week 3 videos? Okay, these videos are already uploaded on the course website, so you can go through these videos. Yeah, you need to submit the assignment before Wednesday. So before that, go through these videos and then solve the assignment. In this assignment, mainly theoretical questions are there. So if you go through the videos, then you will be able to solve the all the problems, all the questions. I will briefly tell about what is a gait cycle. Then I will discuss some important terms here, like important parameters, some of the parameters of gait cycle. So gait cycle is it is the progressive movement of center of gravity because of uh, alternate movements of our feet. Like you can see at this point, the this is the starting point of gait. If we consider our reference feet as right feet, so means when the heel strikes with the ground, at this point the gait cycle starts, and from this position to this position, this is a complete gait cycle. Means first it the heel get contact with the ground, then this the heel is completely means all the foot, the complete right foot is in contact with the ground, then the toe is in contact with the ground, and this is the point where the it is about to taking means the right foot is uh, about to be lifted from the ground, and this point is when the right foot is in the air, means it is the swing phase of the gait cycle. Then again it comes in contact with the ground, and at this point the gait cycle get completed. So like you have different phases. This is the double support phase, means both our feet is in contact with the ground, and this is the next is right single support, means only the right foot is in contact with the ground. Then again comes the double support, then which is followed by left single support. The left foot is in contact and the right foot is in air, it is swinging. Then again the double support phase. So it has the right stance phase, right swing phase, then again left swing phase and left stance phase. See this percentage, how much percentage means you can be asked like what is the percentage of double support phase. See, in a complete gait cycle, we have two double support phase. So if you are asked like what is the percentage of double support phase in a gait cycle, the answer will be 20%, because from here 0 to 10 1%, 0 to 10% is one event, and then 50 to 60 is one event. So we have two events of double support. So in a gait cycle, there are 20% double support phase. The other 80%, 40% is right single support and 40% is left single support. And in our gait cycle, we have some parameters. One is time parameters, which are dependent on time, and the another one is step parameters, which are depends on step. What is the step length? Step length is the length between the successive points of the opposite feet while walking. Like while you are walking, this is your right feet, and this is your left feet. Again, the right feet will come, and again the left feet will come. So, what is the step length? Step length is this length. Means if we consider this point, heel strike point, heel point, then this will be the step length. And the what is stride length? Stride length is the length between the successive points of the same feet in a gait cycle. So uh, this length will be the stride length, and this is the step length. And what is step width? Step width is this width between the two opposite foot. And the from here we will get the time parameters, like the time excuse me, time for one step is known as step time. And what is the double support time? Double support time means time for this double support, for how much time both the feet are in contact with ground. That time will be double support time. And stride means what is the time for this one complete stride. That is known as stride. All these concepts are there in the videos, week 3 videos, so you can go through this. Now we will solve some numerical problems. First, we'll solve one problem on therapeutic intervention for a painful or mechanically unstable hip. So, this is the question. Here it is given the hip joint shown in the figure suffers from chronic pain. If the person has to take the support of a cane for walking, on which side he should hold the cane? And these are some data which is given. This is a cane, and you need to calculate the hip joint reaction force for a cane force of 76 Newton. According to you, on which side he should hold the cane such that he feels comfortable while walking? Means on this side in which there is problem, or on the other side, opposite side, which side he should hold? Can you think about it? Have you all understood the question? So right now we don't know on which side he should hold the cane. So we will solve the problem by considering both the cases. Like first, in the first case, he will hold the cane in this side. This will be our case 1, and this will be our case 2. Then we'll compare our results, and then we can comment like which is the most convenient, which will be the most convenient case for this patient. So I will solve the case 1 here. Let us take this is the joint center, and this is hip abductor force F1, and this is the body weight W.
Sir, who is the joint, hip joint?
Sorry.
Sir, the position O represent the hip joint.
Yeah, 1 second. 1 second, please. Yeah, what was your question? Sorry, I missed your question.
Sir, the figure, the solution figure that you are going to,
Yeah.
from where you are going to explain, there contains O, point O. What does point O represents in the figure?
Okay,
It
okay.
is the hip joint.
Yeah, this point is our point O.
Okay, okay, that's it. Sit up the and then neck.
Yeah, means this is the point where this joint reaction force will act.
Okay.
Okay, so no, okay, so I will take a new slide. This one, uh, this was our point O, and this is the hip abductor muscle force. I am representing as Fm, and here is the body weight W. This is point O, and this was D, and this was D1. The body weight, here it is given the body weight is BW, which is the total body weight, and the total body weight given is this much, 760.6 Newton. But while we will solve the problem, we will not consider the total body weight, because while the person is standing at this point, the person is standing on his right foot. Means this is a right stance phase. right stance position of the person. So the weight of the right foot will not act while he is standing at this position. So we'll subtract the weight of the right foot. So we'll consider only 5 by 6 of the total body weight, 5 by 6 of W. We have subtracted W minus W by 6. This W by 6 is the weight of the right foot. Or right limb. So is it clear while we are considering 5 by 6 W? Okay. And in case of case 1, we are assuming that he is holding the cane on his on the side in which means on the side of the hip in which he has problem. So and we'll assuming this distance as 5 we'll assuming this distance as 10 centimeter. Means here the cane will come, and from O point this distance will be DC. DC is 10 centimeter. 5 by 6 W. And cane force was given, the FC cane force is 76 Newton. So in this figure, what are the unknowns? Only unknown is Fm. Means there is joint reaction force also, but I am not drawing here because first we will find out what is Fm. Then after finding out what is Fm, we can find out the joint reaction force. So this is our step 1. In step 2, we will find out the joint reaction force. Now what I will do the moment equilibrium about point O. Summation MO equal to 0. Because to remains in equilibrium, the moments summation of moments about point O should be 0. So means because of force Fc, we will getting the clockwise moment, and I am assuming clockwise moment as positive. This Fc dot dc, and Fm is with respect to point O. Fm is giving an anti-clockwise moment, so minus Fm dot d, and this 5 by 6 W with respect to point O, it is giving a clockwise moment, plus 5 by 6 W d1. Is this equation clear? Okay. From here we will calculate Fm. We know Fc is 76, DC is 10, minus Fm, what was D? D is 4.39. I will write the letter, say 4.39. D1 is 8.36 W, sorry, 8.64 W is 760.6. 8.64, and one angle is given, abductor angle. What is abductor angle? Abductor angle is the angle between this hip abductor force with the vertical line. So this angle is given 13 degree. So in this figure, this is given 13 degree. Now we will substitute D is 4.39 plus 5 by 6, 60.6. D1 is 8.64 equal to 0. From here we will get Fm. Sorry, Fm equal to, so Fm is 1420.57 Newton, means the muscle force. This is the value of the muscle force, muscle force of hip abductor muscle. So after knowing the Fm, now we'll find out the Fj, which is the joint reaction force. Here we have Fj. How we'll find out the Fj? For this, there are two methods. I have explained in my previous video. In the method one, means we find out the components of force along the x and y directions, and then we apply the equilibrium conditions, and using those equations we solve the unknown forces. And in method 2, what we do the vector method, means we draw a triangle with the help of these force values, and using the formula of the resultant force, we find out the unknown force in that triangle. Now we'll solve using that vector method. First we'll draw the triangle. So we have in the vertical direction we have this weight, body weight. Vertical direction we have body weight, then Fj is acting in this direction, so this is Fj, this is 5 by 6 W, and this is Fm. You can see I am representing all the forces like according to their directions. This 5 by 6 is acting in the vertically downward, then Fj is acting along this direction, and Fm is acting along this direction. And what is given, this angle is given, like if we consider this angle is given 13 degree. So we need this angle alpha. What will be alpha? Yeah, it will be 180 minus 13, which will come as 167. So after knowing alpha, we have one formula for fj, which is fj equal to square root fm square plus 5 by 6 w square minus 2 fm dot 5 by 6 w cos of alpha, which is 167. So using this formula, we will get the value of fj. So if you calculate, you will get 2043.14 Newton. So this amount of force will act on the hip joint. Now I will solve the case 2, which was means the person will hold the can on the opposite side of the hip joint. So case 2 is, this was our O, this was FM D point O, this is 5 by 6 W, and when he hold the can on the opposite side, means this side the can will come on this side. We have FC, then this is D1, DC. So in this case, let us take DC as 40 centimeter and FC was given to us. So again I will first evaluate this FM. This was FJ. I will take the moment equilibrium about point O, summation MO equal to 0. From here, again with respect to point O, this FM is producing anti-clockwise moment, and anti-clockwise we are taking as negative. So minus FM dot D, 5 by 6 W is producing clockwise moment. This FC is producing anti-clockwise, minus FC dot DC equal to 0. FMD was 4.39, was 760.6, 164, minus FC was 76, plus 40. From here we will find out what is FM. FM is 554.97 Newton. Again, we will find the FJ using the vector method. We have 5 by 6 W here. 5 by 6 W, then FJ is acting in this direction. This is FW. And this angle was 167. So using the same formula, Fj equal to square root Fm square minus 2 cos 167. So if you evaluate, you will find out Fj 1181.2 Newton. So in which case the reaction force will be less. See, we got the, yeah, yeah, in case 1 we got this 2043 reaction force, but in case 2 we got almost half of the reaction force than the previous case. So this case it will be more convenient for the person if he holds the can opposite side of his hip. So doctors will prefer to hold the can on the opposite side of the hip joint in which he has problem. So I hope it is clear to everyone. Okay. Anyone has any doubt?
person has problem on this side, the right side. On
Mm.
this,
Mm.
okay. Then he should try to carry the can on his left side
Yeah, yes.
because we are getting lesser blood force in that case.
Yeah. More reaction force means more pain to his joint. That's why he should carry the can on his left side. In that case, he will get the less pain in his joint. Okay, so this is the second problem. Similar problem we solved in our first tutorial, but in that tutorial we were only considering only one muscle force. Here there are three muscles: the biceps brachialis and brachioradialis. This type of problem is also there in the week two. This was there in week two contents, where in the part elbow joint, sir has discussed this problem. Have you gone through that problem and did you solve that problem by yourself?
Sir, I have gone through, but I didn't solve that problem by myself.
Hmm. This is the similar problem. Like it is given that three muscles with attachment points at A1, A2, A3, and theta 1, theta 2, theta 3 be the angles that the biceps brachialis and brachioradialis muscles make with the long axis of the lower arm. Now we need to estimate the muscle forces and humeroradial and humeroulnar joint reaction forces for this position of the arm. These are the given data: total weight of the forearm 83 Newton, weight W naught of the object held 58 Newton, and distance between the axis of rotation of elbow joint and points B and C. This distance B and C, this distance are given 16.5 and 37. And insertion points of biceps brachialis and brachioradialis muscles are given A1, A2, A3. And the distances from the joint axis point O to the points of axon to the forces humerus. These points, these distances are also given. Like in case of brachialis, this distance is 0.08, brachioradialis 0.065, and biceps 0.02 meter out from humerus shaft and at 0.32 meter from O. First, you will, if you see the problem, then you can see that here the question is asking to find out the muscle forces, means FM1, FM2, and FM3. So we have three muscle forces, and what it is asking, it is asking the humeroradial and humeroulnar joint reaction force, means the joint reaction force at point O. So it is asking how many unknowns.
Sir,
No, how it is 3? We have FM1, FM2, FM3. Then they are asking two joint reactions here, FJ1 and FJ2. So we have five unknowns, but we have here we have only three equations, right? We can only write these three equations, which are summation f x equal to 0, summation fy equal to 0, and summation m o about equal to 0. We have only three equations, and we have unknowns, five unknowns. So if the number of unknowns are more than the number of equations, that problem is known as statically indeterminate problem. So this is an example of statically indeterminate problem. There was one question from this statically indeterminate thing, week 0 assignment. So how we will solve this problem? We need more data. We need more data with respect to these muscle forces, FM1, FM2, FM3. Yeah, these are the data given. It is assumed that all three muscles are stressed to the same intensity sigma m. Then the force produced by each muscle will be proportional to its cross-sectional area, and these cross-sectional areas are given. So we will use this data also to solve that problem. First, what we need to do, we need to find out
Sir,
the, yeah, yes,
sir, is it okay to assume that these stresses are same?
yeah,
Is it
means
near to the reality?
means this is the stress intensity. This sigma m is stress intensity. Like this statement is coming from, I have taken this statement from the slide, and I think some experiments means from the literature Sir has taken. Sir has taken this statement from the literature. Like people have already done research, and they have found out that the stress intensity is same for these three muscles. That's why they have reported here. Yeah, so this is an assumption we are taking, but in actual case it may not be different. But in this problem, for solving this problem, we are assuming that it is same. So first we need to find out the moment terms of these muscles, biceps, brachialis and brachioradialis. Like for bicep muscle, these data are given. Distances between axis of rotation, sorry, biceps muscle, yeah, this one. A1 is 3.8, and this is the A1. This horizontal component is A1, and in the humerus 0.02 and 0.32. this is 3.8 and this is given 0.02 and this is 0.32. And we need to find out this OD. OD is the momentum of bicep muscle. We need to find out this OD. So how we will find out? First we will find out this angle.
Sir, so,
Yeah.
sir, please return to the earlier slide, previous slide.
Hmm.
Sir, we are writing, we are drawing the diagram from the last line where it is given that point 110 in our foundation where start.
Yes,
Next
yes,
point.
yes. So is it clear? Yeah. Yeah, so we need to find out this OD. To find out OD, let us take this point as C and this point as E. So we need to find out 10 A1CE. This will be EA1 by OC. It will be 3.8 minus 0.02, which will be 3.78. OC is, sorry, this would be EC. EC is 0.32. So if we calculate this, A1CE will come as 85.16 degree.
This one is very, I think it's near to flat.
Yeah.
This angle.
Mm-hmm. I think I have done some mistake here because see, this is given in centimeter and these are given in meter. So first I need to convert this into centimeter. Sorry. Yeah. Three. This will be 32 centimeter and this will be 2 centimeter. This is 2. This is 32. So 3.78 divided by 32. Yeah, if you calculate this, it will come as 6.7 degree, this angle.
Sir, EA1, EA1,
Hmm?
sir, EA1 is written in 3.78, but it will be
Okay, sorry.
1.8.
Yeah, sorry. Okay, okay, it is 3.2 degree. Okay, so if it is 3.2, then how much? This will also be 3.2, right? This angle DOA1, it is also 3.2. So OD is OA1 into cos 3.2, which will be 3.79. What is this unit? This unit is a centimeter. So we have found out for biceps muscles. Now we need to find out for brachialis and brachioradialis. For brachialis, A2, A2 is 5 and it is 8. 5 and 8, and this is point O, A2, C. So again we will find out this angle, then 5 by 8. So let us take this point as D. OC A2 will be 32 degree. So if it is 32, this angle will be 32 same. So OD is 5 cos 32, which will be 4.24 centimeter. And for brachioradialis, this is a 3 OC. What are the values? 24 and 6.5. OD. Here I am directly calculate. um, OD is coming as 6.27 centimeter.
Sir, 283 is 24 centimeters.
Yeah, it is given in the question. This is A3. Insertion points here. Here it is A3. So now we know the moment terms for all the muscles. So using this data, if we use this data, what will be FM? FM will be sigma m into area of cross section of that muscle. So area of cross sections are given for all the three muscles, and sigma m is unknown here. So we will consider it as sigma m. What will be the total muscle for? What will be muscle force for biceps? Or we will take the moment. Moment produced with respect to O. Moment produced with respect to O because of this biceps muscles. Biceps muscle is at A1. BI. It will be sigma m into area of cross section is 518 into 10 power minus 6. What is the moment term for biceps? It is 3.79. And similarly, moment produced because moment produced by this brachialis muscles BR, it will be sigma m for brachialis 4.24, and the moment produced by the brachioradialis muscle sigma m dot 120 10 power minus 6, it is 6.27. So what will be the total moment produced by all these three muscles? It will be the summation of pi plus here plus here. So we'll only sum 518 multiplied by 3.79 plus 493 4.24 plus 120 6.27. We'll take sigma m and 10 power minus 6 outside the bracket. This value will come as 4805.94 minus 6 sigma m. What is this unit? Unit will be, this is meter square, and 3.79 is this is force multiplied by the centimeter. So unit will be Newton centimeter. This is total moment. why we have added all the moments, because you can see with respect to point O, all these muscles are producing the moments in the same direction, means it is the anti-clockwise direction. That's why we have added all the moments produced by these muscles. Now we'll do the moment equilibrium about point O. Now we'll consider the moment which are produced because of this weight W and weight W naught. And from that equation we'll get the value of sigma m, which is unknown to us. So I'm writing it here. M O equal to 0. We have already calculated the moment produced because of all muscles M, and that was in the anti-clockwise direction. So we'll take it minus plus this moment produced by W into B. It is in clockwise direction. We'll take as positive W into B plus W naught into C. So if we substitute M here, what was our M? 4805.94 10 power minus 6 sigma M plus W was 83 into 16.5 plus W naught is 58 into 37 equal to 0. So if we solve this, we will get the value of sigma m. Sigma m is 7.3 into 10 power 5. What is this unit? This unit was Newton centimeter. I think it is Newton per centimeter square. So after knowing sigma m, we can find out what are the muscle forces. Like for biceps muscle, we'll substitute. This was our force, right? This was our force, and this was the momentum. So we'll substitute sigma m here, then we'll find out the biceps muscle force. F B I 518 into 10 to minus 6. So if we do this, mm, 378.1. Similarly, we'll get brachialis. This is 493. This one. This is 359.8 Newton. And for brachioradialis, um, where is that? Yeah, this is 120. 87.6 Newton. So
Sir, sigma m, the unit of sigma m, that is written here is Newton per centimeter square. So I think it will be 10 to the power 7.
this one.
Yes, because
No, have you calculated?
yes, I have calculated, sir, because the area of the cross section of the muscle is given in meter square. We have multiplied the corresponding the lengths in centimeter. So we should convert that centimeter to meters. 10 power minus 2 will add.
Okay, okay. Yeah. Mm, yeah, it should be in meter square. Mm, this is meter square. Okay, how much you are getting? You are getting 10 to the power 7.
Yeah, 10 power 7 Newton centimeter square. The unit is same,
Okay.
but yes, power will be 7.
Okay, okay. Yeah, thank you. Mm,
So
so,
for FBI, force that is produced by the bicycle.
mm,
On multiplying sigma m 518 into 3 into the moment on into area we will convert it. So I have got it.
means you are asking how we have got this formula. Sigma m into.
No, no, no. No, I have got it.
Okay, okay. So here it will be, if it is 10 power 7, how much you are getting FBI? This force, how much you are getting?
So I am telling you.
Okay.
So 37814 newtons.
Mm,
I am very confused.
see, this unit is meter square and this is centimeter square. So we need to convert this meter square into centimeter square. So we'll multiply it with 10 to the power 4. So it'll be 10 to the power minus 2. it is getting a very huge value, right?
Yes, sir.
I think there is some mistake here in calculating the sigma m.
Okay, sir.
Sigma m 518 meters square, this is centimeter. So what I wrote initially, I wrote here, I think,
10 power 5 kilograms.
yeah. Mm, yeah, I think this will be this one. 10 to the power 5 Newton per meter square. So now if we calculate sigma m, if we calculate now FBI, it will be, yeah, it will be this value only. Can you please check?
Sir, I am checking.
Okay.
Yes, sir, exactly this is the
Yeah, yeah.
one. Sir, it looks reasonable.
Yes, yes. Previously we were getting very large value, which was not getting reasonable to us.
Okay.
So after knowing the muscle forces, like we have calculated what it was asking. We have calculated the first part of the problem, the muscle forces. Now we need to calculate these reaction forces, humeroradial and humeroulnar joint reaction forces. So first I will calculate the humeroradial joint reaction force, and in the radius there are two muscles which are getting attached in the radius. One is this brachioradialis, and one is the biceps. The brachialis muscle is getting attached to ulnar bone, and we'll assume that the weight of the forearm is equally distributed between the radius and ulna. So that means the radius and the weight of radius will be half of this 83, and weight of ulna will be half of this weight. So now I will draw free body diagram for humeroradial joint. If we are considering this as the radius, here we have biceps muscle, and we have this brachioradialis muscle here, and FJ1 is here. What is it? It will be W by 2, and W naught was given by 58. This W naught was carrying by both the bones, both humerus, both radius and ulna. But now we need to find out what is the force which will be carried out by by each of the bones separately. So first we will find out what is the load that will be carried out by the radius bone. Yeah, so we'll take it as W1 here. Now what we'll do, we'll do the moment equilibrium about point O. So this one was our F1, and means muscle force FM1, and this one FM3. So if we consider moment about point O, that will be Fm1 is producing a anti-clockwise moment, that will be positive. Fm1 dot, what was the moment term for bicep muscle? 3.79. And Fm3 brachioradialis 6.27. Next, this W by 2 is producing clockwise, so we are talking at negative. This was 83 by 2, and at what distance it was acting? B is 16.5, and W1 is unknown, it is acting at 37. So Fm1 was 378, 378.1. Fm3, this muscle, 87.6, 6.27 minus 83 by 2, 16.5, W1 37.0. From here we will find out W1. W1 is 35.07. So this load will act on radius bone. So we have known W1. So now we can find out Fj1. How we will find out? We'll take the components, means these horizontal and vertical components, and we'll do the force equilibrium. Let us take this angle as alpha. So if we consider the force equilibrium in x direction, summation fx equal to 0, what will be that one? That will be Fj1 cos alpha minus Fm1. These angles were known to us. This was theta 1 and theta 3. Fm1 cos theta 1 minus Fm3 cos theta 3. So here we have two unknowns. Fj1. No, it will be, we are taking the horizontal. Sorry, okay. This will be, yeah, sorry. Yes, this will be sin alpha. Yeah, thank you for correcting. So we have two unknowns here, Fj1 and alpha. So we will need another equation. That equation will be summation Fy equal to 0. Now we will put here Fj1 alpha Fm1 cos theta 1 plus and if we do summation fy equal to 0, it will be fz1 cos alpha. It is acting in vertically upward, and these components will also act in vertically upward. Plus sin theta 1 plus from here fz1 cos alpha equal to secant theta. So this is our equation 1 and this is equation 2. Now what we'll do, we'll do 1 divided by 2. If we do this, we'll get tan alpha equal to cos theta 1 minus fm1 sin theta 1. So from here we'll get the value of alpha. What was fm1 was 378.1 and fm3 was 87.6. Theta 1 and theta 3. Okay, we have calculated from here. This is theta 1. Theta 1 would be 86.8 degree, and theta 3 will be, this is theta 3, this will be, oh I didn't calculate this. This is 15.5, 15.15 degree. So 86.8 15.15. Alpha is coming as minus 14.57. That means we have considered alpha in this side. So I think fj will act like this. Alpha will come on this side from our data because it is coming as negative. Now we can use this equation to find out the value of fj1. Fj1 will be fj1 is minus 420 Newton. That means the direction will be also be opposite. Like we have assuming it is acting in this direction, but fj1 will act along this direction. So is it clear?
Yes, sir.
Okay. So we have found out this w1.
Yeah. For
So
the
yeah,
radius.
this was carried by the radius bone. So we can find out the load carried by the ulna bone. Means if we now draw the free body diagram of radio ulnar joint, this is the ulna, and in ulna there is one muscle only. This is fm2, and again let us assume fz2 at an angle alpha, and this is theta 2, and here it is w by 2. It will be total weight was let us take it as w. Yeah, so w2 will be 83 minus 35 will be, it will be 49.93. Now I think you can find out these values using the same method like the previous problem.
Yes.
Okay, so now you can do it by yourself. This is B and this is C. These distances are given. W2 is known to us, W by 2 is known to us, and W2 is already known. So again you will do summation fx equal to 0 and summation fy equal to 0, and using these two equations you will find out fz2 and alpha. So I think you can do, right?
Yes. Sir,
Oh,
please, have you got those values? If you know, then please write it so that I can match it.
okay.
Otherwise, I will.
Yeah, yeah. I will give those values.
Okay.
Means while I will upload this slide, I will write here fz2 and
Okay.
alpha. Okay.
Okay. Sir, so we have find the joint reaction forces for the radio femoral joint and
Hmm.
the humeral and ulnar joint and the
Yes.
muscle forces.
Yes. Yes.
Okay,
Yeah, yeah, yes. So, do you have any doubt? Have you understood it properly?
Yes, sir. Very properly I have understood. Sir, I have seen the lectures of sir
Hmm.
in slides, but I have now practicing with my own copy with your with you
Yeah, yeah, yeah,
for clear. I think I can solve these problems.
yeah. So, if you are giving the main exam for certification,
Yes, sir.
are you giving the exam for
Yes,
certification?
sir. Yes, sir. I agree.
Yeah, yeah. In that exam, these type of problems may come. So,
Okay.
in the assignments, there are not such numerical problems. There are problems only based on the theory.
Yes,
But in the main exam, this type of problem may come. So that's why I think these problems are there in the slide.
yes, sir.
Mm. So by
That is
practicing this problem will be helpful for you. Yeah. Okay. Do you have any doubt, Durgaras?
I'll refer and
Okay.
I'll tell you the
Yeah. Yeah. Okay.
next. Sure. Sir, can I have the question problem? The question of the problem.
Means yeah.
Yeah.
You can take a screenshot. Yeah.
Yes, yes, yes.
Mm.
Yes, sir, I am taking that.
Okay. Okay. So if you don't have any doubt, then we can close. Uh, we'll again meet on next Saturday. Next Saturday, same time.
Sir, sir,
Yeah. Yeah.
the
Yes.
timing we will meet on Saturday.
Yeah. We'll meet on every Saturday, every week.
No, this it cannot be changed.
No, the time slot is already fixed. Means
Okay.
yeah.
Okay, sir. Thank you, sir.
Okay. Yeah. Thank you. Thank you for joining.